like we factored quadratics. So they would be trinomials, 3 terms, or binomial, 2 terms that are like the difference of squares, but they are not squares. Maybe they're to the 4th, maybe they're to the 8th, something like that. As an example, I'll just do one from the book. It's to the 4th minus x squared minus 15. So for this to work, it's got to be 3 terms. And they've got to go down like this, 4, 2, 0, 8, 4, 0, even and evenly spaced. Okay? I'm going to show you 2 ways to do this, one way that the book describes and one way that the video described, and see which one you like. Okay? What I will do is do the bottoms up like normal. Minus 30. So this would be x squared, not just x, minus 6, and x squared plus 5. Because I have to get an x to the 4th when I multiply these together. And it has to equal 1 here. And it has to equal negative 30 here. And if I multiply, if I FOIL this, I get x to the 4th plus 5x squared minus 6x squared is negative 1x squared. Okay? When you factor like this, you always have to look and see if there's another factoring that you could do here. I could possibly do something here if this was a perfect square. But it's not. Okay? So now I'm going to divide this by 2. X squared minus 3 and 2x squared plus 5. That's the final factoring then. Okay? What the video tried to show you is kind of an algorithm, something a process you can use to keep it organized on a piece of paper. So what they did is they let u, just this letter u, this is called u substitution. We're just going to make up this u term and let it equal x squared, this middle term. So now I could rewrite this like that, because x squared squared is x to the 4th, and u is x squared, that's the middle term, minus 15. So now it looks like a quadratic. Okay, and now when we do this, we can do it the same way. That becomes u minus 6, u plus 5, divide by 2, u minus 3, 2u plus 5. And now at the very end, you just take whatever u is and plug it back in. So x squared minus 3, 2x squared plus 5 equals the same thing.
That's a lot.
Well, what it does is it makes it look like a quadratic, which you're comfortable with. Okay, the trick here is figuring out what you want to replace u with, or x, what you want to make u. That's the trick. Okay, let's try a difference of squares. Minus 16. The u substitution. Okay, if I wanted to make this a difference of 2 squares, what squared is x to the 6th? What squared is x to the 6th? X to the... X to what? Yeah. Is x to the 6th. What it... u, or x cubed, right? Right? So what I could do is let u equal x cubed and rewrite this as u squared minus 16. Okay? And now it's the difference of 2 squares. The square root of u is just u. Square root of 16 is 4. And then I write it twice. That's the pattern we learned last chapter. And now I'm going to take whatever I had back in. And I'm done.
That's easy.
That's confusing.
Okay, the other way you could look at it is just look at this without any substitution and just ask yourself the square root of x to the 6th, x to the 3rd. So I would make this x to the 3rd plus 4, x to the 3rd minus 4.
So that's
So like I said, I've presented both ways. Some of you like to use substitution because it just gives you a system. Some of you can just look at it and do it. Okay, whenever you see a polynomial, the degree of the polynomial tells you how many solutions there are. So if it's an x to the 4th polynomial, there'll be 4 solutions. X to the 5th, 5 solutions. Not all of them may be real. Some might be imaginary. Okay. But if I look at, what do I want to do here? Let's factor and all, okay. Minus 51x cubed minus 27x. Okay. This wants us to find all solutions. So the first thing I need to do is factor. And before you even jump into any special factoring, you always look for the greatest common factor. What's common to all 3?
3.
And x. Okay, when I pull a 3x out of here, what do I have left?
3x squared? No, you couldn't. Never mind. Sorry.
3. Just me.
So 6, 2x, 4 minus 13. No.
No, it's 17.
Okay, everybody agree so far?
Yeah.
Factor time equals 7.
Okay, now we have 4, 2, 0, so it's a pattern that we can use a quadratic factoring technique for. Okay, so if I look at, this would become 2x to the 4th minus 17x squared minus 9. Multiply those, x to the 4th minus 17x squared minus 18. Factors of 18 that equal 17. 18 and 1, what's positive, what's negative?
Positive
18.
negative 1.
No, negative 18.
Positive.
Negative 18.
Oh, yeah.
Is that right?
Yes, it is.
Okay, so now, but this is divided by 2, and this is divided by 2, right?
Yes.
Okay, so now I factored it this far. 3x times x squared minus 9 times 2x squared plus 1.
Equals 0.
Okay, is there any other factoring I can do here now?
Put it in.
Huh?
X squared is negative 9.
No. X squared minus 9. I'm trying to break it apart, not put it together.
I know you don't have to put that. You don't have to deliver that 3 back into the first equation.
No, I don't want to put it back in. I'm trying to factor everything out. So how do I factor this?
Divided by 2.
It's a special factoring. It's a difference of squares.
So 30 is 9.
X plus 3, x minus 3. That's how this factors.
Yep.
And then I have 2x squared plus 1 equals 0. I'm trying to solve this. I'm trying to break it apart. Yes. Okay, so now, using the zero product property that says if I'm going to multiply all these and get 0, each one of these has to be 0. So I would say 3x is 0, x plus 3 is 0, x minus 3 is 0, and 2x squared plus 1 is 0. So to solve this one, x is 0. To solve this one, x is negative 3, positive 3, and then to solve this, I subtract 1,
Negative 1/2. Square root of that negative 1.
plus or minus negative right? So it's going to be imaginary.
So
It's going to be plus or minus 1/2 I,
1/4.
1/2, the square root of 4.
Oh, 1/2 I, yeah.
Plus or minus 1/2 I. Okay, so if I was asked to find the real solutions, there's only 3. Even though it started out with a 5th up here, we know there's 5 total solutions, but only 3 of these solutions were real, 2 of them are imaginary.
Hey, that was the problem of the thing.
Mhm.
I thought that was right.
Okay. Let's go through the textbook check. I don't know where I'm going. Quizzes.
Get a rocket there.
Okay, if you're asked to solve a polynomial and have it factored, which is one we just did, there's 3 real solutions. 2 of them are imaginary. 3x to the 4th minus 25 would be factored using the difference of cubes formula. False. Difference of squares, because they're both perfect squares. The square root of 36x to the 4th is 6x squared, and the square root of 25 is 5. So this would be 6x squared plus 5, 6x squared minus 5.
Wait.
In the following factored polynomial equation, x equals 0 is a solution. True. Because you have to set each one of those equal to 0 and solve. In the video, a strategy is introduced that's not discussed in the textbook. What's the strategy? Substitution. You recognize that 81x to the 4th minus 16 is a difference of squares and factor it this far. Is this the correct factorization? No. Because this is a difference of 2 squares. So it can be factored further. 3x plus 2, 3x minus 2. Then times 9x squared plus 4. You always have to factor it to the possible least amount before it's done.
Wait, you said then plus 9x squared plus 4?
Yeah, so this factors to 3x plus 2, 3x minus 2.
The other one factor?
It's a difference of squares that factors.
Oh.
The sum of squares can't be factored.
Oh, difference minus, okay. I remember.
Okay. Tomorrow we learn long division with polynomials.
Yay!
I know,
You know how long it's been since I've done long
I
division?
know. And then Wednesday, no school.
You
Yeah.
mean that thing where you had to like do this and then
I don't even
start
remember.
there?
3.
With the subtraction?
It's almost